This is Greg Guyar here with your Scribe of the Day notes for September 18th, 2009. Factoring out the numerator and the denominator is a great way to solve division problems. Let's take a look at this one example. So we have 156 over 12 here. Now, you've probably all done it in your heads by now, but let's see what we can do with this. Let's factor out the numerator into two separate factors, 12 and 13. Now, in this case, the second step you would do is you would cancel out all the common factors. In this case, you see there's a 12 in the numerator and a 12 in the denominator. So, we cancel them out, and you're left with 13. Sometimes you just have ugly numbers that you just can't factor, or don't want to factor. Take, for example, 335,412 over 63. It's going to probably take 10 times as long to factor that, so let's do long division instead. So the point here is that we have to find what number 63 will fit into the dividend. It won't fit into 3, it won't fit into 33 either. However, it will fit into 335. So, how many times does 63 fit into 335? That would be 5 times. So we'll put that 5 up there, multiply it by 63, and we get 315. Subtract that from 335 and we get 20. And then we have to bring down the 4 as well, leaving us with 204 below the line. Next, how many times does 63 go into 204, that number we now have? That goes in 3 times. 3 times 63 is 189. Subtracted from 204, we get 15. And we bring down the 1. Next, again, 63 into 151, 2 times obviously. 2 times 63 is 126. Subtracted from 151, you get 25. You see I've run out of room there. And we bring down the 2. And next, 63 goes into 252 4 times. 4 times 63 is 252, so we wind up with a remainder of 0. So this one works out perfectly. Using factoring to solve algebraic division problems isn't that much different. Again, we're going to look for common factors in both the numerator and the denominator. Factoring the numerator, we get x minus 4 times x plus 2 over x plus 2. And as you can see, x plus 2 is in both the numerator and the denominator, so we can cancel them out, and we are left with x minus 4. Sometimes there's just no way to factor either the numerator or the denominator, or it's just not as efficient as doing long division. So to do long division for algebraic problems, it takes a slightly different approach, and I'm sure some of you have a different way of going about the process for this. But the way I like to think about it is this. You want to find some term that, multiplied by the highest degree term in the divisor, equals the highest degree term remaining in the dividend. So x is the highest degree in the divisor, and at present 5x cubed is the highest degree in the divisor. In the dividend, excuse me. What times x equals 5x cubed? That's 5x squared. And we'll put that right above the cubic term and multiply 5x squared by x plus 4. So we're going to get another binomial. 5x cubed is what we were aiming for, and now we have 20x squared to go along with it. We'll subtract that from the top, and we get negative 2x squared minus 6x. So now we have to eliminate negative 2x squared. So again, what times x equals negative 2x squared? Negative 2x. Multiply that out, and we get negative 2x squared minus 8x. So subtracting them, we get 2x, and we bring down the constant coefficient of 1. From there, we know that 2 times x is 2x, multiply again and subtract, and look at this, we have a remainder. Of course, we can express that remainder in a different way. Sorry about the misprint there. Negative 7 over x plus 4. You could simply express the solution, therefore, as 5x squared minus 2x plus 2, and then plus 7 over x plus 4. So there's just one more trick here. Let's put all the dividend into the synthetic substitution and take all the coefficients. So you recognize 5, 18, negative 6, and 1 from the original one. But negative 4, it does have to do with the divisor. It was x plus 4, as you recall. And if your divisor is in the form x minus a, then you should be putting a as the number you should be multiplying all your synthetic results by. So since it's x minus negative 4, then negative 4 is what you multiply everything by. So to do substitution, you know how this works by now. You drop the 5 down and multiply it by negative 4, you get negative 20, and then just keep adding and multiplying down the line. So now, let's recall our original solution. And you notice that every result is exactly the same down the line. All the coefficients line up, and even the remainder. So, there's another method to solve division problems. This has been Greg Guyar with your Scribe Notes for September 18th. Thank you very much.